I we're going to look into question 10, which is the first organic chemistry, alkene versus alkene. So let's dive into things. This is going to be a 12 mark question here. Okay, so let's get going. With the first question, we are looking at details about alkane, alkene. They can react with bromine, but under different condition. Give a reason why ethane does not undergo addition reaction with bromine. Addition reaction does not. Okay, the idea here is because first you must be able to clarify that alkane is the one. Sorry, I should write here. CC single bond, and then for alkenes, ENE, that's the CC double bond. Okay, the idea is addition reaction is only reserved for the alkene family because the alkene family has the double bond that can open up and add in new things. Okay, so with ethane here, there is no CC double bond, so there is no addition reaction. Okay, next one for part 2. Complete the reaction for substitution reaction. So substitution is for the alkane family. Again, it is the CC single bond family. Substitution, because they have no double bond, they can only break off one bond at a time and substitute with another element. And in this case, they can react with not just bromine, but any halogen. There is an essential condition for this to happen. It is UV light. Now, without the presence of UV light, the BR-BR bond cannot be broken, so the reaction will not take place. So this is a must for substitution reaction to take place. Again, it doesn't have to be bromine, it can be chlorine as well. So how does this work then? If I were to draw out this C2H6 molecule, I'm going to just take this away. C2H6, okay, and my hydrogen is here. I'm just going to focus on one hydrogen at a time, probably this hydrogen. And I also have a BR, bromine, that can be broken off. So this bromine here would substitute with the H. So what we have here will be C2H5Br, one hydrogen less, but the addition of Br. So where is this H going to? It is going to be combined with the other Br that has not been substituted. So we end up with a small side product of HBr here. Okay, so condition is UV light. And what is the observed color change? The alkene family is, in fact, we're looking at the alkene, the CC double bond family here. This one, when alkene, so in this case, ethene react with bromine water, this is an addition reaction. So the bromine water, which is supposed to be orange, so it's going to use this color. Bromine water is, the original color is orange. It will turn colorless in this case. Okay, so things to take note about bromine. If it's bromine water, in this case, it's dissolved in water, it is orange. If it's bromine in the element form, okay, this bromine exists as liquid at room temperature, it is reddish brown. So please don't get them confused. At the same time, I'm going to talk about iodine. Iodine, when it's dissolved in water, iodine, when it is in its elemental form, which is a solid, then and then we have what is the color that we want to talk about? Oh, iodine that's in gaseous form. Okay, so in its elemental form at room temperature and pressure, it is gray. If sublimation, it turns purple. If it's dissolved in water, it is brown. Okay, so take note of that. So that's our a little bit of halogen, part of the periodic table group 7 that you need to take note of. Okay, so this question focus on alkenes, and they give two different display formula. You know what's coming out, right? The isomer here. Okay, so they are asking you about homologous series first. And they have stated in the question that if substance belong to the same homologous series, they will have the same general formula. That means this is given. You should not mention anything else about general formula. So that leave you with a few options. You could say that homologous series, compound in the same homologous series have the same functional group. That means like if it's from alcohol, then it's OH. Ooh, what's happening? Give me a minute to find my question. There you go. Okay, so this is the question. Okay, again, homologous series. The two characteristics of the same homologous series. And they have given you same general formula, so please don't repeat this. If it's in the same homologous series, they will have the same functional group. And what do we mean by functional group? It would be like if it's alkene, CC double bond. If it's alcohol, OH. These are the same functional group. In the same homologous series, they will also have same chemical properties, things to take note, and then there's a trend in physical properties. So take note of these two words here. If it's chemical property, same. If it's physical property, is trend, because like things like melting and boiling point change based on the molecular size. Okay, boiling point, melting point usually get is usually higher as the molecular size increases. Okay, then the favorite question here is why the two alkene in the diagram are isomer. You can see that they actually have the same number of C's and actually the same number of H's. What makes them different is just the way they are structured. So the way to answer isomer question is they have the same molecular formula but different display or structural formula. So take note of this. This is a very common memory question. Okay, things that you should not be writing, or the common error student code here would be those in red crosses. Okay, with isomer, they always need you to draw another isomer. So you are looking at 4 C's and 1, 2, 3, 4, 5, 6, 7, 8, 8 H's. Okay, so 4 C's, 8 H's. So the best way to do it is you draw 3 C's in a row with an extended methyl group, a CH3 from the middle C. Okay, so you would want to take note of things like that. Always check that carbon has 4 bonds. And for this case, you need to ensure that there's a CC double bond in the middle. I'm going to take away my highlighter in red, like that. Okay, so it's still an alkene, but it is a different structure. Okay. Finally, for part C, this is a 3-mark question. It proved to be quite difficult for some students because the question demand is a little bit high. Okay, so first we are trying to describe. In case you didn't manage to catch it, if it's described, you just need to list down and you don't need to explain the why. Okay, so what do they want you to talk about? They want you to talk about the difference between the reactant and the product. Now, at this point of time, are you able to identify which one is the reactant? It is before the arrow, and the product is after the arrow. So in this case, reactant is our ethene, and then product is our polyethylene, the plastic. Okay, they want you to be very clear that you are going to talk about chain length, and this is what they actually recommend, and I'm going to strongly encourage you to do this as well, because there's so many things you need to focus on. Underline what you need to talk about and put a number right on top of it. Say, so in this case, you want to, number one, the first point you want to talk about is the carbon chain length. Number 2 is the type bond. Number 3 is the state of metals. So 3 things to talk about, and you want to compare between the reactant and the product. So the first one, so chain length. Polyethylene, which is the plastic, in this case the product, has a longer chain length than ethene. Say for example, you should be able to identify ethene, right? If not, you could say the product has a longer chain length than the reactant. That's also fine. Okay. Then number 2, because we want to talk about type of bonds now. So polyethylene contains only single covalent bond, but ethene contains C double bonds. Okay, and then finally, which is the hardest for a lot of students, is polyethylene. The state of metal, that means at room temperature and pressure. Plastic, as we all know, is a solid, but this is the part that a lot of students are unaware of. Ethene is actually existing as a gas. In fact, the first four alkenes, they are gases. Okay, and for iGCSE Pearson and Excel, they actually only need you to know the first 4 alkene and alkene. All right, so the last one is a little bit hard to score as a hit or miss for a lot of students because students are unaware that alkene, in ethene in this case, is a guess. So hopefully this 12-mark question has been quite helpful. I think the last 3-mark question can be a little bit difficult, and you should go on and try out a little bit more isomer questions. Definition for isomer is really popular, and also learning how to draw isomer, that's usually a 1 or 2-mark question. So please spend some time to practice and revise on that. All right, see you on the other side for the last and final question for 2024 November-October paper.